Hello everyone. So today I'm going to show you how to transform a certain function into its Fourier series. Okay, so all you need to do is memorize the Fourier series transformation formula, the a sub 0, the a sub n, and b sub n. So all you need to do is memorize these four important formulas, and for optional, you may use these formulas for for better solving. So okay, so I'm gonna explain how to use these formulas right here while we are solving a certain problem. Okay, so let's say we're going to find the Fourier series of a function f of x is equals to x, right? So we need to transform this into its Fourier series. So let's start it simple, but the solving is not really that simple. So okay, so first things first, let's write the formula of the Fourier transformation. Infinity n is equals to 1 an cosine n pi x over p plus bn sine n pi x over p. So that's the formula. So we need to find first the a sub 0. So the a sub 0, as we all know, it's 1 over p, the definite integral of p has a boundary of negative p to p f of x over dx. So by the way, we need to define the boundaries of the certain function, which I forgot, which is the interval is negative 2 is less than x, x is less than 2, right? So p here is the highest limit in the function, which is the highest limit is 2. So that's our p. So a sub 0 is equals to 1 over 2. It's negative 2 to the f of x, which is the x function, dx, right? So you can just directly plug this one to the calculator, and we should get that's x, lower bound is negative 2, upper bound is positive 2, which is gonna multiply it to 1/2, and we will get 0. So this will be our first partial answer. Our a sub 0 is equals to 0. Right, so that's, we have the a sub 0. Next is we need to find the a sub n. So this is where things starts to get messy. So we all know an is equals to 1 over p negative p f of x cosine n pi x over p dx. So we will just substitute the available variables. P is 2, that should be negative 2 to 2, f of x is x, cosine n pi x over our p is still 2, and dx. Okay, so in this part we have two variables, two x's, so we need to use the integration by parts, right? Okay, so integration by parts, we have, I put it in the side, we have, that's u, no, I should gonna put it in this side, u dv is equals to uv minus v du. So our u here is x, our du is dx, our dv is cosine and pi x over 2 dx, and then we'll integrate that. We should have, so in order to integrate this one, all you need to do is just, so the derivative of cosine is sine, right? And we just need to follow this formula right here so that everything will be easier. Since we have cosine, so all you need to do is just switch the p, put it in the top, and then the n and pi, put it in the bottom, and then multiply it to the integral of cosine, which is sine, and then exactly copy all of the angle or the inside of cosine, the inside of sine, right? So I hope you get that. So that's the pattern right there. Okay, so we need to put the 2 at the top, there you go, and then the n pi at the bottom. The integral of cosine is sine, and then exactly copy what's inside the cosine. Alright, so that's it. That's basically it. So we have here the exact we have here the integration by parts, and all we need to do is just substitute it right back to the equation. So an is equals to 1 over 2. Since we already integrated this part, which is right here, and we just need to follow the uv here. So our u, follow this, our u is x, our v is 2 n pi sine n pi x over 2, and then minus the integration, which is still negative 2, then our v is 2 n pi sine n pi x over 2 dx, because we still not really integrated in this part. And there you have it. Alright, so next step is just basically integrate this part again, and we only have one variable x here. Instead, in this part we have double x. That's why we use the integration by parts, because we have two x's here. So our goal is to have it 1, and we have 1 here, so we're just gonna directly integrate this part without the use of integration by parts. Okay, so an is equals to 1/2. So basically copy this, 2 n pi sine n pi x over 2. Okay, so we need to integrate this part. We can move the 2 n pi outside, so 2 n pi, and then integrate. So we only left with sine. So the formula or the integration of sine is, as we all know, is negative cosine, and as we did, we just need to put the 2 at the top, the n pi at the bottom, and the negative cosine, and exactly copy this, the whole fraction. So we have negative, so since the integral of sine is negative cosine, so we're just gonna put the negative. So 2 at the top, the n pi at the bottom, cosine, and exactly copy what's inside the sine. Okay, and don't forget we still have the negative 2 and 2 as the boundaries. So next step is we just have to simplify this equation so that we can solve it much better. So we can put the x in the inside, 2x and pi sine and pi x over 2, and then since negative 2 times negative 2 is just positive 2 and pi squared plus 2 and pi squared, and then just copy the cosine and pi x over 2. So our goal here is just make it smaller so that it will not be messy to solve to when we put these boundaries, because we still have the boundaries. Okay, so now we should put the boundaries. Okay, so since we have 1/2 and 1/2 at the outside here, we can use this formula at exactly right here. So just imagine this is the 1/2, and then once the 1/2 is inside and our inside is sine and x, which is in our case that's just this one big inside the brackets. So we can just use this one formula, or we can just directly copy it both. So just gonna copy it both. Okay, so we have 1/2, so just substitute the values. So that's 2, 2, 2, that's 4, and pi sine and pi 2, 2 plus 2 and pi 2 cosine and pi 2, 2. Right, so minus, so we're just gonna put it at the bottom. We have minus 1/2 so we substitute the negative 2, so that's 2 negative 2 and pi sine and pi negative 2 over 2 plus 2 and pi 2 cosine and pi negative 2, 2. So you guys should have a foundations in integration and derivative at this point, because I'm not gonna explain anything how to use derive. So far we have this. So we're just gonna need to simplify. So 1/2, that's 2, 2. So I'm just gonna make it 2 squared, which is just basically 4, and pi sine, you can cancel the 2. So we can cancel the 2, so we have n, just n pi, and then plus 2 and pi 2 cosine, cancel the 2, we have n pi here, and that's it. Minus, I'm gonna go at this at the bottom, so we have minus, so we got the 1/2 2 times 2, that's just negative 2 squared, just basically negative 4. Okay, and then sine, cancel, but we should put the negative because that's negative, and pi. Okay, plus 2 and pi 2 cosine cancel, and that's negative n pi. Okay, so we have this. Next is we're just gonna simplify it further. So we're just gonna put the 1/2 inside. So that's 4. 4 divided by 2, that's 1/2. It's basically 2 n pi. Put the brackets here, sine n pi. That's 2 times 2 squared at both. So that's 4, and then we're just gonna divide it by 2. We will left 2 n pi squared, and copy cosine n pi. So that's negative, that's positive, and left it positive. 2, 4, the same at the first one. We have 2 n pi sine negative, n pi plus the same. We will left with 2 n pi squared cosine negative n pi. Right, so we left with this. So we have here sine n pi, cosine n pi, sine negative n pi, and cosine negative n pi. It's okay. So we're just gonna follow this formula right here. So we have simplifying trigonometric identities with n in angle. So as you can see, basically, if it is cosine, it is cosine, and then we have a n angles here, n pi. Regardless if it's negative n pi or negative cosine n pi, the answer should always be negative 1 to the power of n. So if it's cosine, it's automatically negative 1 over n. And then we have here sine, regardless if it is negative n pi, sine negative n pi, or negative sine n pi, sine n pi. If it is sine, it is automatically 0. Okay, so if it's cosine, that's negative 1 to the power of n. If sine, it's automatically 0. Okay, so we have here an, we have sine. Okay, so we have sine, as we all know, that is equals to 0. So, plus 2 negative n pi squared cosine. If it's cosine, that's negative 1 over n, plus 2 n pi sine, with sine, that's a 0, plus 2 n pi squared. If it's cosine, that's negative 1 over n. Okay, so with 0, it's negative 1, that's 0, it's negative 1. If it's 0, automatically 0, cancel out, and we will left with these small values, which is 2 n pi squared negative 1 n plus, oh wait, this, wait, this should be positive, this should be negative, because we have negative 1/2 here. So if we put it, if we put it at this part, if we distribute it, the answer should be negative. So this one should be negative, sorry. Okay, so we have negative 2 n pi squared negative 1 over n. Okay, so that's negative n pi 2 squared. As you can see, they are basically the same. This one and this one are the same, just their signs are different. We have positive, we have negative here. In that case, that all is 0. So an will now be equal to 0. Okay, so we have an and a sub 0 so far. So we all left with bn. Okay, so bn is exactly the same formula as an, just change the cosine into sine. So that's bn is equals to 1 over p negative p f of x sine n pi x over p dx. Okay, so we all know our p is 2. 1 over 2, that's 1/2. Negative 2. Our function is x. And wait, our sine n pi x over 2 dx. So since we have 2 x's here, we will use the integration by parts. So integration by parts is u dv is equals to uv minus v du. Okay, so our u is x, our du is just add dx, our dv is sine n pi x over 2 dx, and then v is we just need to integrate this. So the integration of sine, that is still cosine. Okay, that's cosine, which is negative. That's negative. Okay. It has the same method as in the first one. So we have again, we have the integration of sine, that's negative cosine, and then just put the 2 at the top, the n pi at the bottom. There you go, that's cosine, and exactly copy what is inside the sine. There you go. So that's your function right there. That's your formula for the integration by parts. So just need to put it back to the equation for bn. So we have our u is x, our v is negative 2 n pi cosine n pi x over 2. All right, so next is minus integration, that's negative 2 to our v is negative 2 n pi cosine n pi x over 2. All right, and dx. Okay, so that's it. That's our dv, and our du, that's dx. So I put it right there. Okay, there we go. So we'll just need to copy this except the integration part by x over 2. Alright, so we can remove this actually, or we can just right. So again, we can put outside the n pi, that's negative, that makes it positive. Okay, so we all left with this one. So the integral of cosine is sine, and we're just gonna exactly copy what we did before. Let's put the 2 at the top and pi at the bottom. That's sine n pi x over 2 go. And for the top, there you go, because we have double here. And don't forget the boundaries, because we still have the boundaries. Okay, so we're just gonna simplify it a little bit. So that's 1/2. We can put now the x, add the 2 and pi cosine and pi x over 2. Okay, and then plus 2 and pi 2 and pi sine and pi x over 2. All right, so we need to simplify it a little bit more. So it's 1/2 negative 2x and pi cosine and pi x over 2. So this one is just basically 2 and pi squared, and then copy sine and pi x over 2. Okay, so at this part I think it is pretty much okay to substitute now the values for the boundaries. Okay, so that's first we have the positive 2, that's 1/2 negative 2 to 2 and pi cosine and pi 2 over 2 plus 2 and pi 2 sine and pi 2 minus 1/2 negative 2 and pi cosine and pi negative 2 plus 2 and pi 2 sine and pi negative 2. All right, so just need to simplify it, so that will be negative 2 to 2 is 4. We're just gonna make it 2 squared. It's negative, and pi cosine cancel, we'll be left with n pi plus 2 and pi squared sine cancel, we have left with n pi. That's it. Next is negative 1/2, or just minus 1/2. That's negative times negative 1 times, because we have negative here, we have negative here, and then negative 2 4. That's basically positive. That's 2 squared, and n pi cosine cancel, but it is negative 1, negative n pi plus 2 n pi squared, and then sine cancel, it is negative 1 sine negative n pi. There you go. So just need to simplify it a little bit further. We will now distribute the 1/2. Okay, so that's 2 squared, that's 4 divided by 2, that would be negative 2 n pi cosine n pi. That's 2 squared all over n pi squared, and then divided by half, we have still 2 n pi squared, and then sine n pi, and then close, plus that's negative 2, that's 2 squared 4, minus that's negative divided by negative half, and we should get negative 2 n pi. cosine negative n pi plus 2 squared for all over n pi squared n pi square of multiplying those two divided by negative 1/2. We should get a negative answer, which is negative 2 n pi squared sine negative n pi. Okay, so from the previous step, if it's cosine, it is negative 1 over n, and if it is sine, automatically 0. Negative 2 n pi cosine, that's negative 1 over n, plus 2 n pi squared sine 0, plus negative 2 n pi, that's cosine negative 1 over n, minus 2 n pi squared, and sine, we have 0. Okay, so now we can cancel if it's automatically 0, and we should have negative 2 n pi negative 1 n plus negative 2 n pi negative 1 n. Okay, so we need to simplify this a bit further. We have bn, let's say, so since they have the same variables, so we can just add them both. That's negative 2 negative 2, negative 2 plus negative 2, that's negative 4 over n pi, and then negative 1 n. So we have here our bn. So that's our bn. So now we have an, bn, we have a sub 0, a sub n, and b sub n. Okay, so now it is all complete. We know that an is 0, so we're gonna put it here. A sub 0 is 0, a sub n is also 0, but our b sub n has a value, that's negative 4 n pi negative 1 n. Okay, so we will copy first the Fourier series transformation formula. 2 plus infinity 0 n is equals to 1 an cosine n pi x over p plus bn sine n pi x over p. Let's not forget our p is 2. Okay, so now let's substitute the values. So a sub 0 is 0 over 2 plus infinity n is equals to 1. Our an is 0. 0 cosine n pi x over 2. Our bn is negative 4 n pi negative 1 n. Alright, that's our bn sine n pi x over 2. Okay, so we have this value. So automatically that's 0 divided by 2. As we all know, that's 0. And this is also 0. Okay, so we'll have left is just the summation, the negative 4 n pi negative 1 n sine n pi x over 2. So this could be the answer, or we could put the pi at the on the outside and the variable. So we're just gonna transfer the 4 and pi at the outside, which is this one and this one. for formality, so just copy inside. That's negative, and that's negative, negative 1n. So you should not, it is recommended not to simplify this. Just keep it as is, the negative 1 to the power of n. That's n. Pi is already at the outside, so you're gonna copy a sine n pi x over 2. So this is the Fourier transformation of f of x is equals to x. Okay, so thank you very much for watching. And wait, I forgot the one. There you go. Okay, so I think this is the final answer, and thank you very much for watching. This is the Fourier series. So this is the overall solution. So thank you very much.